Good morning. Let's continue with multiple reactions. So today's topic, series multiple reactions. Series parallel reactions. Series parallel reactions. So what are the series parallel reactions? I have already explained what are the series parallel reactions. Okay, so let me take one example and continue with the derivation. Yeah. It is A plus B gives R and R plus B gives S with the rate constants K1 and K2. So here I'll be developing the equations to find CR max. Okay, CR max. And how do we find the concentration? See, suppose CA is available for me and CA naught is available for me and CA I can find. But how do we actually find CR, CS, CB is the discussion, and I'll be deriving some equations to find the concentrations of these components. That is it. That's it. Okay, it may be R. Usually R is a desired product, so we will try to develop the equations to derive the form to get equations to get R. Okay, so yeah, let me start with let me use the board fully. Okay, so if I write minus RA, this will be K1 CA CB. Okay, and let me mute this. And if the same equation, if I write this as plus RA, it will be K1 CA CB minus K1 CA CA CB. And if I write RR, it will be minus K1 C. Oh, R is a product, right? If I take that as a product, it will plus K1 CA CB minus K2 CR CB. And if I try to write RB, I don't need anyway in the derivation, but let me write that so that you'll get used to how to write these things. Okay, it's confusion. RB will be, it is minus K1 CA CB minus K2 CR CB. Okay, and RS will be K2 CR CB. Okay, so this is how we write the rate equations. And let me call this as 1, 2, 3, 4. Now, main aim is, I consider A as a main reactant and R is a desired product. R is a desired product. So, okay, so let us now concentrate on R and A. Okay, so, I'll write RR by RA, which will be, actually what is RR? RR will be dCr by dt and RA will be dCA by dt. Okay. So if I take RR by RA, it will be dCr by dCA, which will be equal to dCRS RS K1 CA CB minus K2 CR CB by RA is plus RA, it is right. So I'll take minus K1 CA CB. Okay, and this will reduce to minus 1 plus K2 by K1 and CR by CA. This will be the equation. dCr by dCA. Okay. So now this is of the form dy by dx plus py is equal to q. And you know the solution for this equation. Solution for this equation is y into e to the power of integral p dx is equal to integral of q into e to the power of integral p dx into dx plus c. This is the solution for the equation. Okay. So now what do I have y as? If we continue. Okay, here y is equal to CR, x is equal to CA, P is equal to K2 by K1 into CA, K2 by K1 into CA, okay, and so 1 second, it will be minus K2 by, because I'll be sending that, I'll rewrite it, okay, anyway, DCR by DCA minus K2 by K1 into CR by CA is equal to minus 1, okay. So P will be minus K2 by K1 into CA and Q will be minus 1. Minus 1, okay. So now the solution will be, if I write the solution, y, it is CR e to the power of integral of minus K2 by K1 CA into DCA will be equal to integral of what is Q minus 1 into e to the power of same thing minus K2 by K1 CA DCA, okay, into DCA plus C. This will be the solution. Okay. So now I have to simplify this. So CR, this can be written as e to the power of minus K2 by K1 ln CA. This will be equal to integral of minus 1 e to the power of minus K2 by K1 ln CA into DCA plus C. Okay, and we know e power minus x ln y is equal to y power minus x. We know this, okay, e to the power of minus x ln y is equal to y to the power of minus x. So I can now write this equation as CR into CA power minus K2 by K1 is equal to integral of minus 1 CA power minus K2 by K1 into DCA plus C. Okay, so this can be rewritten as CR into CA power minus K2 by K1, and the integration will be minus 1 into CA power minus K2 by K1 plus 1 by minus K2 by K1 plus 1 plus C. Okay, so this will be minus 1 into 1 by 1 minus, I'll take this as 1 minus 1 minus K2 by K1 into CA to the power of minus K2 by K1 plus 1 plus C. Okay, so this is a minus K2 by K1. Okay, so now what I do, I have to find the constant of integration. So to find the constant of integration, it is at t is equal to 0. At t is equal to 0, what will be CA? CA is CA naught. CA is equal to CA naught. And CR naught will be equal to, CA naught at t is equal to 0, concentration of A is CA naught only. And CR naught will be 0. Okay, CA is equal to CA naught. Correct it is. And CR naught will be equal to 0. Okay. So now the next step is finding the value for C, the constant of integration. Okay. So let me find the value for that. So this will CR, this is 0, right? So I can now write this as C is equal to this minus, if it comes to the other side, this becomes plus 1 into, this is as such 1 minus K2 by K1, and this will be CA naught to the power of minus K2 by K1 plus 1. So you got the value for C. Now the equation will be CR, CR CA power minus K2 by K1 will be equal to minus 1 into CA to the power of minus K2 by K1 plus 1 by minus K2 by K1 plus 1 plus C. What is C? C is, I have found the value for C here. It is again, it is Ca naught into minus K2 by K1 plus 1 by 1 minus K2 by K1. Okay. Yeah. So here also I can write this as 1 minus K2 by K1. 1 minus K2 by K1. So this is the equation. This is the equation. Okay. And yeah. So now I'll again let me consider this equation and continue with the simplification. Rewrite that equation here in the LHS. What I'll do, I'll send this term to LHS, sorry, RHS, okay, and then write the equation. So, yeah, CR, therefore, CR will be, let me rewrite the equation and then continue, I think that will be more comfortable. CR is CR into Ca to the power of minus K2 by K1 is equal to minus 1 into minus K2 by K1 plus 1 by 1 minus K2 by K1 plus Ca naught to the power of minus K2 by K1 plus 1 by 1 minus K2 by K1. Okay, I've just shifted this equation here. I've just copied that. Okay, now what I'll do, I'll send this term to RHS. I'll send this term to RHS. Okay, therefore, CR will now be 1 by 1 minus K2 by K1 can be taken common, and this will be minus 1 into Ca to the power of minus K2 by K1 plus 1. If this comes to denominator and if I take this up, it will be plus K2 by K1 plus Ca naught to the power of minus K2 by K1 plus 1 by Ca to the power of minus K2 by K1. Okay, this is the equation. Now what I do, I divide the entire equation by Ca naught. So Cr by Ca naught will be equal to 1 by 1 minus K2 by K1 into what am I left with? Minus of Ca by Ca naught only, because this term goes off. Okay, and so here it is plus Ca naught by Ca to the power of minus K2 by K1, and here also it is minus K2 by K1 plus 1 minus 1. Divide by Ca naught, the entire equation by Ca naught. This is what you get. Okay, therefore Cr by Ca naught is equal to, which form I have kept as, okay, it is K1 by K1 minus K2 into Ca naught by Ca to the power of minus K2 by K1 minus Ca by Ca naught is the solution. This is the solution when K1 not equal to K2. Here K1 is not equal to K2. Okay. Next, if K1 equal to K2. Next case, make a note of that. Next case, if K1 is equal to K2. Okay. Okay. So for that, all the other things till here it remains the same. Till, yeah, I can consider till here. Okay. So from the beginning till you get this step, you have to repeat writing it. Okay, you have to repeat writing this till you arrive at this stage. Okay, so from here I'll continue. K1 is equal to K2 if K1 is equal to K2. So yeah, so this will be CR CA par minus 1 is equal to this will be integral of minus 1 CA par minus 1 BCA plus C. Okay, so this will now be CR by CA is equal to minus 1 into DCA by CA ln CA plus C. Okay, ln CA plus C. Minus ln CA plus C. Okay, what is the next stage? Next stage is at T is equal to 0, CA is equal to CA naught, and CR is equal to 0. So from this you can get a value for C. What is at C? C will be ln CA naught plus ln CA naught in this equation. Okay. Therefore, now CR by CA will be equal to minus ln of CA plus ln of CA naught plus ln of CA naught. Okay. If we continue here only. Now what I'll do, I'll divide the entire equation by CA naught. So if I divide this entire equation by CA naught, what we get here is CR by CA naught, and this CA I'll take to LHS, CA by CA naught into minus, okay, this can be written as ln of CA naught by CA. That's it, okay? So this is your equation. This is your equation when K2 equal to K1. Make a note of that. K2 equal to K1. Okay? Yes. So now let us continue with finding CR max. How do we find CR max for both the cases? CR max if K1 is equal to K2 and CR max if K1 not equal to K2. Okay. Yes. So first, let me start with CR max for K1 equal to K2. That is more simple. Okay. Yeah. So I'll go with the same equation. I'll rub this part. We'll continue here. So which equation I'll take here is the last equation. Let me take the last equation. CR is equal to CA into ln CA naught minus ln CA. To find this, I'm doing to find CR max. Okay. Okay. Can see? Yes. I'm now finding CR max for K1 not sorry, K1 equal to K2. Okay. Yeah. So how to find CR max? You just recollect what you have done in previous derivation. DCR by DCA will be equal to 0 at T is equal to T max. Okay. So at T max, DCR by DCA will be equal to 0. Now what I'll do, I'll find DCR by DCA for this equation. So the DCR by DCA will be, so this is CA into 0 minus ln CA is 1 by CA plus this term ln CA naught minus ln CA into 1. So to find CR max, CR will and CR is equal to CR max. Correct. So here this will be equal to 0 and CR will be CR max, wherever has CR. Okay. Yeah. So this will be, so this is 0 is equal to CA goes off and I'm left with minus 1 plus ln of CA naught by CA. Therefore, ln of CA naught by CA will be equal to 1. Will be equal to 1. Okay. Therefore, CA naught by CA will be equal to e to the power of 1. I can write this e to the power of 1. Okay, okay, let me come at this stage. Or CA is equal to CA naught by E. This is what you can write. Okay. Now I have got an expression. I have got an expression for CA. So this CA has to be substituted in this equation to get CR max. That's it. Okay. To get CR max, we will substitute this value for CR here, CA here. And this equation will now be CR max by CA naught is equal to CA by CA naught. This can be written as 1 by E. Okay. Into ln of CA naught by C is E. So this will be 1 by E into E, ln E, this is 1, right? Ln E is 1. 1. Okay. So CR max by CA naught is equal to 1 by E. Okay. Very simple. And therefore, CR max by CA naught, if you find the value, it is equal to 1 by E, and if you find the value, it is 1 by E 0.368. 0.368. This is your value for CR max at K1 is equal to K2. Make a note of that. So you have two relations here. CR by CA naught when K1 is equal to K2. There's a relation here, and for the same case K1 by K2, you have got the values for CR max by CA naught. Okay, yeah, note it. Too much of mathematics, but you have to go through. Next is to find CR max when K1 is not equal to K2. I don't need all these things. Okay. To find CR max when K1 not equal to K2. Okay. So here, let me recollect the equation which I had taken, which I have derived. Okay. Equation I'll take is CR is equal to 1 by K2 by K1 minus 1 into CA naught. CA naught to the power minus K2 by K1 plus 1 divided by CA power minus K2 by K1 minus CA. Okay. So we have already developed this equation. We have derived this equation. I'm taking that. I'll consider that equation and continue. Okay. Make a note of this equation. Okay. Yeah. So this is actually very simple. What I do in the next step. So next step, I'll divide this by CA naught. Did I take the correct equation? Let me check once, because yeah, check on the correct equation. Okay. Yeah. So to find CR max, how do we do? CR by DCA is equal to 0, and CR will be CR max. At this condition, CR becomes CR max. Okay. So what should I do now? I should find DCR by DCA for this equation. So how do I do that? Yeah. DCR by DCA for this equation will be 1 by K2 by K1 minus 1 into CA naught is constant minus K2 by K1 plus 1. So here this CA I'll take up, and I can write that as K2 by K1 into CA to the power of K2 by K1 minus 1. Okay. And differentiation of this will be minus 1. Note this term. Okay. Yeah. So this is equal to 0. This is equal to 0. So from this, I can get an expression for CA now. So that CA will be, therefore, CA will be, this will be the 1 by K2 by K1. Okay. And so CA naught will come down, and when it goes up, it will be K2 by K1 minus 1. Am I correct writing? Yeah. Did I miss anything? Okay, CA to the power of K2 by K1 minus 1 is there. Okay. So, therefore, from this, what can I write? CA by CA naught. Both have common powers. K2 by K1 minus 1 will be equal to K1 by K2. Important thing. Okay. So once we have this, this CA has to be substituted here to get an expression for CR max. Okay. So let us substitute now. It is better to have CA only separate, right? So that we can substitute that easily. Therefore, CA to the CA will be equal to K1 by K2 into K1 by K2 to the power of 1 by K1 by, see this one I'm taking to RHS, so K1 by K2 minus K1 and CA naught. Simple. Now what I'll do, I'll substitute the value for that this CA has to be substituted in this equation to get CR max. Okay, therefore CR max now will be equal to CR max will be equal to 1 by K2 by K1 minus 1 into CA naught to the power of minus K2 by K1 plus 1 by CA. I should substitute. CA will be K1 by K2 to the power of K1 by K2 minus K1 into CA naught. CA naught. It is just CA naught, right? CA, yeah, correct. Okay, one simple method. Actually, if we just alter this equation and take the simplification, will be easier. What I'll now do, because I'll be getting CA by CA naught, right? So here I can write this as CA by CA naught is equal to K1 by K2, K1 by K2 minus K1. What I'll do in this equation, I'll try to have this term in all the places. Okay, so this will be, therefore CR will be 1 by K2 minus 1. This makes my work simple. If I see the complications here, I think this method makes my work simple. So yeah, it is CR. What I'm doing is I'm dividing the entire equation by CA naught. Okay, so CA naught by CA naught to the power minus K2 by K1 plus 1. If I am dividing, it will be minus 1 again. CA naught, this denominator CA naught will go up. Okay, and CA to the power of minus K2 by K1 minus CA by CA naught. Okay. Thanks. Do one more simplification step here. So this will be 1 by K2 by K1 minus 1 into CA naught by CA to the power of minus K2 by K1 minus CA by CA. So if I have the equation in this form, it is much easier for me to substitute. Okay, now I'll substitute this Ca in this equation. So when I was trying to substitute here, it was becoming a little difficult. Okay, yeah, let us substitute now. Therefore, Cr by Ca naught will be equal to Cr by Ca naught will be equal to 1 by K2 by K1 minus 1 into Ca naught by Ca. Okay, I have Ca by Ca naught, right? Yeah. So if I take Ca naught by Ca, it will be K1 by K2 minus K1 by K2 minus K1. Okay. Minus Ca by Ca naught. K1 by K2. K1 by K2 minus K1. Did I miss something? Ca by Ca naught. Okay. So now you simplify this. You simplify this equation to yield the equation of the form. Too much of mathematics. I will leave this to you. Simplify this. Cr max by Ca naught will now be K1 by K2 into K2 by K2 minus K1. This is for what? When K1 not equal to K2. Okay. Simplification you can do in any way. See, I have Ca by Ca naught, right? Okay, if you want, I can simplify that also. One step I'll substitute and later you can do. Here it is simple. Ca by Ca naught is K1 by K2 into that I substituted. And for this Ca naught by Ca will be 1 by, okay, K1 by K2 to the power of minus K1 by K2 minus K1 into what do I have? Minus K2 by K1. K2 by K1. Okay. So I have after this, okay, you can simplify. So what am I left with? Okay, in between one step I'll write. So this will be what I've taken. Okay. K1 by K2 minus K1 into K2. What are we left with? K2 by K2 minus K1 minus K1 by K2 into K1 by K2 minus K1. Okay. Now next steps are very simple. Take this common. Take this common and simplify to get this equation. Okay. So this is the final equation. Only two steps I have left for you. You should be able to do it. Yes. Oof. Next is finding the concentrations of other components. So we know how to find R now. If we know how to find R, Ca is given. Ca naught is a given value. And if we know how to find R, we should be able to find the other concentration. What are the other concentration? B and S. Yeah. This is all about the quantitative treatment in a PFR and a batch reactor. MFR is very, very simple. Okay, coming to finding. Concentrations. Finding concentrations. Okay. So we know Ca naught plus Cr naught plus Cs naught. Whatever is taken should come out as Ca plus Cr plus Cs. Okay. So if we take Ca naught minus Ca, plus CR naught minus CR plus CS naught minus CS. This will be equal to 0. So I can write delta CA plus delta CR plus delta CS will be equal to 0. Okay. Next is balance for B. Balance for B. Okay. So total B reacted is total B reacted will be CB naught minus CB. Okay. And total B reacted towards S. Total B reacted towards S will be CS naught minus CS. Okay. So what will be then total B reacted towards R? So towards R it will be this minus this CB naught minus CB minus of CS naught minus CS. Okay. So this is total reacted towards R. Okay. So now balance for R. Balance for R. So I'll write the equation CR naught is what? Initial. Plus, see, if so much is reacted towards R, then this much of R is formed. Plus R formed. See, we contribute so much towards R means this much of R has to be formed. So R formed will be CB naught minus CB minus CS naught minus CS. Okay. So this should be equal to CR plus CS minus C naught. Okay. So this is used for S. Used for yes. Okay. So now what you do? You just simplify this, and to get an expression, I'll write the expression minus of CB minus CB naught minus CR minus CR naught minus 2 times CS minus CS naught is equal to 0. You just take the products and simplify. And the final equation here is delta CR plus delta CB plus 2 delta CS will be equal to 0. This is my equation which is required. Make a note of that. Okay. Yes. Next is quantitative treatment for MFR. The same series parallel reaction, quantitative treatment if it's an MFR. Quantitative treatment MFR. Okay. Yeah. So these equations I'll not repeat. What is the performance equation? I'll go with performance equation is equal to CA naught minus CA by minus RA, which can also be written as CR naught minus CR by minus RR. Okay, but we know what is minus RA and what is minus RR from the previous slide written, right? A plus B gives R plus B gives S, K1, K2. When I wrote this, I had written what is minus RA, what is minus RR. K1, CA, and repeat anyway. K1, CA, CB minus K2, CR, CB. Oh, it is minus RR, right? So this is plus. Minus RR I am taking. Previously I written that as plus RR. Okay. So minus RR. So now this will be CA naught minus CA by minus RA is K1 CA CB. This will be equal to CR naught minus CR by minus RR is K1 CA CB plus K2 CR CB. Okay. So now what I'll do? Actually, CR naught will be 0. Initially, it is 0 only. So what I'll do? Minus CR by CA naught minus CA will be equal to minus K1 CA CD plus K2 CR CD by K1 CA CD. This will be equal to minus 1 plus K2 by K1 into CR by CB is equal to minus CR by CA naught minus CA. Okay, or you can write this as CR is equal to minus of CA naught minus CA to minus 1 plus K2 by K1 into CR by CB. Okay, so you can write this. And the final expression, I'll write the final expression so you derive that final expression. It is simple. So CR will be equal to CA into CA naught minus CA by CA plus K2 by K1 into CA naught minus CA, and CR max you derive it, and CR max here is CR max by CA naught is equal to 1 by 1 plus K2 by K1 half whole square. This is the expression. Okay. Oops, lot of mathematics. Let's wind up. Thank you.